Hello, everyone, and welcome to my 10.2 bonus video. Let's make myself here a little bit bigger if I can. There we go. So yes, in this video, we're continuing the saga of parametric equations. Last time in 10.1, we learned a lot about the algebra side of things for parametric equations. 10.2 is a lot more on the calculus side of things, where we're interested in slopes of tangent lines, equations of tangent lines, arc length, things like that, all very calculus related things with our parametric equations and our parametric curves. And so in this video here, again, I'm going over a more difficult style problem. We're asked to find a slope of a tangent line or tangent lines where this curve crosses itself. And a couple things that make this more difficult is, first of all, well, there's trig functions, and that's usually, on the upper end of the spectrum as far as these sorts of questions go. And then the other thing, right, is that some of the earlier questions we're given a specific time value, right? So I guess maybe let's back up just a step here before I get to that, right? We are going to get to trying to find slopes of tangent lines. And so slopes of tangent lines, right, we're going to be using our equation rise over run. So how the y's are changing with respect to time versus how the x's are changing with respect to time. And that'll be all good and everything, but we need to plug in a time value. And in this problem right here, it doesn't tell us a time value, right? It just says where the curves crosses itself. And so we have to find that. And so that kind of is the extra step here. And so if you would, please pause the video, take 90 seconds, 2 minutes or so, try to find the time where this curve actually crosses itself. And then come back, unpause the video, and we'll go over the results together. Okay, so I'm here at Desmos, and I think this is a really good way to visualize where the graph is going to be crossing itself. In fact, we can see it right now. Of course, we'll get into here just in a second, pretending that this is a quiz or an exam question, and we will do this graph by hand. But the big thing here is that we would like to graph the curve using our 10.1 knowledge, right? We need to be able to see where the graph crosses itself. And when you want to see a graph, right, well, actually making the curve itself, and plotting all these points is a good way to go. But while I'm here, right, I just wanted to point out that Desmos can accept parametric curves. You do the x coordinate, then you do the y coordinate, and I have time steps from 0 to 100. Right here, you can see we've got a nice closed curve, so I suspect that this is all of it. And then I also did the same thing, but with A here, and I have A as a changing point. And so just so that way I can hit this play button, and we can kind of see how we transverse this curve as we go from our t value of 0 to our t value of 2 pi. Of course, sine is periodic. It has a period of 2 pi, and so it's not really surprising that this thing is repeating itself every 2 pi. Okay, and so with that, why don't we go ahead and switch over to the iPad here and see how can we do this by hand. All right, so here we are on my iPad, and again, I want to figure out where this curve crosses itself just by hand. And so again, one really good way that you could go about doing this is by sketching the curve, right? We know now using our 10.1 knowledge, we can make a couple of tables and we could go about it that way. And again, what you would expect to see here, and maybe we can do this, it won't take too long. So let me do, again, my X's, my Y's, and of course my T's. Maybe I should have put my T's out front. Here I'm going to do something like 0, pi over 2, and pi. And maybe to just get a little bit more of a clear picture, let's do pi over 4. Oops, I want pi over 4 up. It's less than pi over 2. And 3 pi over 4. So we could start off with those. And then, let's see where that gets us. And then we'll kind of continue a little bit farther beyond that. So if I plug in 0 into both of my equations, into my x equation, into my y equation, of course, we get 0, 0. If I plug in pi over 4, well, pi over 4 into this equation right here, right, we get 3 sine of t. So 3 sine of pi over 4. And remember, sine of pi over 4 is around 0.7 or so. It's this root 2 over 2. So if I multiply that by 3, 0.7 by 3, right, this is going to be around 2.1. Okay, it's a little bit nicer here for my x's, right? If I plug in pi over 4, I get to multiply this by 2. And so when I multiply this by 2, we get pi over 2. And sine of pi over 2 is equal to 1. So this is going to be equal to 2. Okay, if I plug in pi over 2 next, we can check that y is going to be 3, because again, sine of pi over 2 is going to be 1 times that 3 there. And 2 times pi over 2 is going to be pi. Sine of pi is 0. And when I multiply that by 2, well, we still get 0. And so again, kind of we could go ahead and start sketching these. We have 0, 0 first. Then we have over here at 2, 1 and, x value of 2 and a y value of 2.1. So maybe something like that. And then next up, we have an x value of 0 and a y value of 3, something like that. So I know that it's going to be something like this so far if I connect these dots with a smooth curve, right? Okay, and then we could continue 3 pi over 4. If I plug that into my y value, sine of 3 pi over 4 is going to be, again, root 2 over 2. Nice and positive there. So that's around 0.7. Multiply that by 3. Again, we're going to get 2.1. And now when we plug in 3 pi over 4 into my x values here, again, when I multiply that by 2, I'm going to get 3 pi over 2. So sine of 3 pi over 2 is going to be negative 1. Multiply that by the 2, we're going to get negative 2 here. And so that's why it's going to be over here. X value of negative 2, y value of 2.1. And then finally, when I plug in pi, we're going to get the y value, 3 sine of pi. Well, sine of pi is 0. And the x value, 2 sine of 2 pi. 2 pi, right? Also, the sine value there is 0. So multiply that by 2, you still get 0. And so you can see here at pi, we actually hit this 0.00 again, right? Of course, we already saw the Desmos graph, and if you wanted to, you could continue this with just a few more points, right? And you can see that you're going to get this bottom half as well. And now you have a pretty good picture, and you know where this graph is going to be crossing itself. It's going to be crossing itself at the time values of 0 and pi. We can also, with this picture, get a decent idea of what our final answer should be looking like, right? We're interested in the slopes of the tangent lines. And so I'm really expecting that one of our slopes to be negative, something like that, and one of our slopes to be positive. So if I got something out at the end of the day that wasn't one negative slope and one positive slope, right, I would be a bit concerned. And also there's some symmetry going on here. And so we'll see that, right, these slopes are very much related to one another. And so, okay, this is kind of one of the fastest ways, I think, in order to show that the graph crosses itself at 0 and pi. This graph is periodic, so it does repeat itself every 2 pi. So again, kind of, we saw in the Desmos that it kind of, here's 0 to pi, pi to 2 pi, and then it just kind of keeps on going over and over again, sort of deal. So, but again, only this value at 0 and pi in this period of the range 0 to 2 pi, right? This is the only place where it crosses itself. So this would be a relatively fast way to get this done as far as a quiz and exam. But again, this is a problem that's on the upper end of the spectrum, certainly. And so this would have to take a minute in order to solve this out. Okay, so now that we have this, we are very interested at 0 and at pi. Those are going to be our 2 time values where the curve crosses itself. And so now we want to figure out the slopes of the tangent lines. And this is a little bit more standard, right? This initial bit of trying to figure out where it crosses itself, that was maybe a bit more difficult to figure out what we needed to do there. By the way, a fun kind of side problem before I get into the slopes of the tangent line is, can you solve that same problem using just algebra, right? Without using the graph there, can you come up with these values of 0 and pi just using algebra? And I think you can, but it's hard to rule out some other points. And so I do think kind of the graph is a good way to go. But I invite you to, pause the video, take, 3 minutes, 5 minutes, however long it takes. And I suspect you'll see that the algebra is difficult on this one. Algebra with trig functions quite often is. So, okay, now let's get back to the slopes of the tangent lines. So again, as we learned in 10.2, the slope of the tangent line is going to be our rise over run. Nothing really new there, except for with these parametric stuff, right? Our rise, our y values depend on time. So when I say rise, I mean, how is y changing with respect to time? And our run is going to be how is x changing with respect to time. So rise over run, these are derivatives, right? We need to take the derivative of y with respect to time. We need to take the derivative of x with respect to time. And so let's go back up to our equations here. The derivative of y with respect to time, well, the derivative of sine is going to be cosine. So we're going to have 3 cosine of t. And the derivative of x with respect to t, well, again, the derivative of sine is cosine, but we do have a little bit of a chain rule going on here. So I need to take the derivative of the inside. The derivative of 2t is going to be 2. So if you'd like to, you can combine these like terms here. 2 and 2 are going to make 4. Okay, now we're going to plug in our specific time values. So I'm just going to say at t equals 0 and at t equals pi. And so if I plug in t equals 0 into this, right, cosine of 0 is equal to 1. Again, I'm thinking about my unit circle here, and cosine is supposed to be the x values. How much do you move left or right? And if I have an angle of 0 degrees or 0 radians here, right, I'm to the right, all the way to the right, that measure of 1 there. And so we have 3 times 1. Okay, well, cosine of, 2 times 0. 2 times 0 is still going to be 0. And so this is going to be 3/4, right? Because again, we're going to have another 1 there in the denominator. So again, this is going to be 3/4 is going to be that slope there. Now, on the other hand, when we plug in pi, we're going to have 3 times cosine of pi. Cosine of pi, right? If I go pi radians, that's going to be over here. The cosine value, aka the horizontal value, how much we moved left and right, is now to the left by 1, right? And so to the left, -1. On the other hand, in the denominator, I'm going to have 4 cosine of not pi, but 2 pi, right? Because we need to multiply it by 2. And so 2 pi, I'm going to go all the way around, and we're going to get back to where we started here. And so again, the cosine value, how much we move left and right to achieve this point on the unit circle, right? This is to the right by 1. And so now we can see we have the -3/4. So again, we have one nice positive value, 3/4. We have one negative value, -3/4. So this is making a lot of sense. Plus, you can kind of see the symmetry, right? That this is kind of a graph that's been reflected vertically in order to achieve this. And so maybe it's not surprising, right? If you reflect a slope of 3/4 vertically, right, you're going to get -3/4. And so, yes, this is making a lot of sense to me. So okay. Anyway, the answer to this problem, right, is 3/4 and -3/4. Those are the two slopes of the tangent lines where this curve crosses itself. All right. Thank you so much for watching, guys. I hope you have a wonderful day, and I'll see you out there.